This is Chapter 8.2, Quick Review, Exercise 1 through 10. This section has to do with ellipses, and this is the preliminary to working with ellipses. We're going to go over the odd number problems in this set, and this set has to do with kind of multiple skills from earlier in Algebra 2 and Precalculus, even Algebra 1. And Exercise 1 to find the distance between the given points. What we have for that is something called a distance formula, and you might remember this from Algebra 1. Its distance is equal to the square root of, we have x sub 1, or excuse me, x sub 2 minus x sub 1 squared plus quantity y sub 2 minus y sub 1 squared. And sometimes you'll hear them say x 1 instead of x sub 1. I like to say sub. And then just identifying what they are with these points, we're going to have x sub 1, y sub 1. That's going to be negative 3 is x sub 1, negative 2 is y sub 1. And then 2 is x sub 2, and 4 is y sub 2. So if we just plug in to this formula here, we're going to have x sub 2, which is 2, minus x sub 1, which is negative 3, and that's going to be squared, plus y sub 2, which is 4, minus y sub 1, which is negative 2. And so we have this quantity here, so our distance is equal to 2 minus negative 3, that's going to be 5. And 4 minus negative 2 is 6. So we have d is equal to square root of 25 plus 36. And 25 plus 36 is, I believe, 61. So our distance between these 2 points is the square root of 61. And if we go ahead and look at problem 2 is similar but different in the way that you're going to just have to use the formula. You're not going to be able to simplify because you don't have pure numbers to work with. So you can use x sub 1, y sub 1 here, and a is going to be x sub 2, and b is going to be y sub 2, and then use that same formula that we used in problem 1, and you're just going to fill in that formula, and that's going to be as far as you can go. Okay. Next odd number problem. Now in exercise 3 and 4, solve for y in terms of x. Now this is the equation of an ellipse, so this is preliminary to working with ellipses. So we're going to solve for y. And to solve for y, we're going to subtract x squared over 4 from both sides of this equation, and x squared over 4 minus x squared over 4 cancel out. So we have y squared over 9 is equal to 1 minus x squared over 4. And if we cross multiply the 9, we're going to have y squared is equal to 9 minus 9/4 x squared. And so what we're going to do for this one is we're going to factor out 9/4 from each of these terms, and it's going to be, I hope, apparent why that's the case. So we'll say y squared is equal to 9/4. Well, 9/4 times what equals 9? Well, that's going to be 4. And then minus x squared. And so the next step we're going to do is to take the square root of both sides. And I'm just going to come up here to the top and write y squared equals 9/4 24 minus x squared And what we're going to do is take the square root of both sides of this equation. And so square root of y squared is y, and y equals, well, we take the square root of 9 over 4. Well, that's going to be 3 halves. And then this 4 minus x squared, we're going to have the square root of 24 minus x squared. Now, I will tell you that we took the square root, and so taking the square root of both sides, we're going to have plus or minus 3 halves. And what this is going to do is give us an ellipse with an upper half and a lower half. So this will be essentially two functions. It'll be y equals 3 halves square root of 4 minus x squared, and also y equals negative 3 halves square root of 24 minus x squared. And considered together, this will compose an ellipse. The plus 1 is going to be that top half of the ellipse. The bottom one, this negative 1, is going to be the bottom half of that ellipse. And problem 4 is very similar. I'm just going to go ahead and put down the answer for problem 4 so you can see if you got this right. That's going to be y equals plus or minus 5/6. And we have the square root of 36 minus x squared. So just for purposes of checking your work on problem 4. Next, problem 5, solve for x algebraically. And what we have is this expression, square root of 23x plus 12 plus the square root of 23x minus 8 equals 10. So I'm going to just rewrite these. (3x plus 12 plus square root of quantity 3x minus 8 is equal to 10. And so that's going to be 3x. Okay, that looks more legible. Okay, next step we're going to do on this is we're going to square both sides of this equation. Okay, and when we square both sides of this equation, this square root of 23x plus 12 becomes just 3x plus 12, and this 3x minus 8, we're just going to say plus 3x minus 8, and then we're going to have plus 2 times the product of these two square roots. So it's just like using FOIL or some other method. So we're going to have 2 times the square root of quantity 3x plus 12 times the square root of quantity 3x minus 8 is equal to 100. 10 squared is 100. And the next thing we're going to do is combine these like terms on the left. So 3x plus 3x, that's going to be 6x. And then 12 minus 8, that's going to be plus 4. And we're going to have plus 2 square root quantity 3x plus 12 times square root of quantity 3x minus 8 is equal to 100. Okay. The next thing we're going to do is we're going to subtract 4 and 6x from both sides of this equation. So subtract 6x, subtract 4 from the left side of the equation. From the right side, we got to subtract 6x and 4, and we're going to end up with, on the left side, 2 times quantity 3x plus 12 times quantity 3x minus 8 is equal to we're going to have negative 6x, and 100 minus 4 is going to be plus 96. The next thing we're going to do here is we can divide by 2. So dividing by 2 from all terms, we're going to have on the left side quantity 3x plus 12 times quantity 3x minus 8 is equal to negative 6 divided by 2 is 3, so we're going to minus 3x, and then 96 divided by 2 is going to be plus 48. And the next thing we're going to do after that is square both sides of this equation. And I'm just going to bring this up to the top here. I'm going to kind of work below at the right here. So I'm going to take square root of 3x plus 12 times the square root of quantity 3x minus 8 is equal to negative 3x plus 48, kind of run out of room, squared. And so I'm going to square both sides here. And when we square both sides here, we're going to have 3x, well, I'm going to keep the equal sign in the middle here. Let me just take out the equal sign here. We're going to have quantity 3x plus 12 times quantity 3x minus 8 is equal to, and we square everything on the right, we're going to have 9x squared, and then we're going to have that's going to be negative 288x, and then we're going to have plus 48 squared, which is going to be plus 2304. I'm just kind of run out of room here, so I'm going to just kind of echelon below here. Plus 2304. And then just kind of multiplying out on the left side, we're going to have 3x squared times 3x times 3x, so we're going to have 9x squared, and we're going to have minus 36x. This is the left side I'm working out here. Minus 8 times 3, which would be minus 24x. And then, let's see, that's going to be 12 times 3, that's going to be plus 36x. That's right, minus 24x. And that's going to be minus 8 times 12. And 8 times 12 is going to be minus 96. And on the right side, we still have 9x squared minus 288x plus 2304. And on both sides of the equation, we have 9x squared over 9x squared cancel each other. And bringing down what we have left, we have 36x minus 24x, so we have 12x. And then, let's see, minus 96. (12x minus 96) is equal to negative 288x plus 2304. And then if we add 96 to both sides of this equation, So I'll put plus 96 here on the left and plus 96 on the right. And if we'll add 288x to both sides of this equation. Plus 288x. Let me just see if I can write that a little more legibly. Plus 288x. And it's 288x. Okay. Plus 96. And so we have as cancellation, negative 96 plus 96 cancel left side, negative 288x plus 288x cancel the right side. And what we have left is 300x is equal to 2304 plus 96, which is going to be 2400. And next, if we divide by 300, we have x is equal to 8, which is our correct answer. Now, the next odd number problem is 7. I'll just take a look at, let me look at 6 here. 6, same type of process, but in 6, we're, instead of adding here, we're going to be subtracting. But I thought they were all addition for this one. Anyway, that can be worked out. On a 7, what I did for problem 7 is, owing to the length of the video and working out problem 7, what I did in the next slide, I'm showing the entire working out of problem 7. So here's problem 7 worked out in a similar fashion to problem 5, but in this case it's the same type of process. And we're squaring and simplifying, and it turns out we get down here on the lower right, we get square root of x squared equals square root of 4, so x equals plus or minus 2. And as one last thing, we can solve this by graphing. If we solve this equation for 0, we take square root of quantity 6x squared plus 12 plus square root of quantity 6x squared plus 1 equals 11. If we subtract 11 from the right side, we set the right side equal to 0. So we go to a calculator where I already have this entered, the left side. I'm just going to subtract 11 and then press enter. And what we do is we get a solution. We get solutions at x equals negative 2 and x equals 2. And so just by graphing, these can be done pretty easily by graphing. So here it is by graphing x equals plus or minus 2. Next odd number problem we're going to look at, problem 8 gets kind of involved. It is doable without a calculator. And let me put the solution for these problems here. I forgot, for problem 6, the solution is going to be x equals 4. And for problem, so you can just check your work. And for problem 8, the solution is going to be x equals plus or minus 2, just to check your work. Okay, problem 9, exercise 9 and 10, find exact solutions by completing the square. And just looking at this function here, we're going to kind of go through, that might be a while. I like getting things in terms of x squared, so if I have 2x squared minus 6x minus 3 is equal to 0, I like to just have plain x squared. So if we divide this whole equation by 2, everything by 2, we can do that. We're going to get x squared minus 3x minus 3 halves is equal to 0. And what I'm going to do is clear out that minus 3 halves from the left side by adding 3 halves to both sides of this equation. So we're going to get x squared minus 3x equals 3 over 2. Now to complete the square, we got to take this coefficient of x, which is negative 3, divide that by 2. And then we're going to square that. So what we're going to get for this is negative 3 squared is 9, and 2 squared is 4. So we're going to have to add 9/4 to both sides of this equation. Okay, so we get x squared minus 3x plus 9/4 equals 9/4 plus 3/2. Well, 3/2, right to the right, is equal to 6/4. So 3/2 plus 9/4 is going to be 6/4. I'm just going to write 6/4 plus 9/4 equals 15/4. Okay, so now I'm going to come up to the right and work to the right here. So I'm going to get x squared, I'm just going to write out, minus 3x plus 9/4 is equal to 15/4. And what we have is we can write this x squared minus 3x plus 9/4 as a perfect square of quantity x. We have minus 3/2, right? X minus 3/2 times quantity x minus 3/2 is equal to 15/4. And for that, we have x minus 3/2 quantity squared equals 15/4. So we can take the square root of both sides here, and what we get is x minus 3/2 is equal to plus or minus square root of 15/4. Over 2, excuse me, 15/2. In solving, we get, adding 3/2 to both sides, we have x equals plus or minus square root of 15 square root of 15 over 2 plus 3/2, and that's going to be equal to 3 plus or minus square root of 15 over 2. So that's going to be our two-part answer, two solutions here. So completing the square. And then for number 10, here's number 10, and when you work this out, you're going to get x equals negative 1 plus or minus square root of 7/2. So that's all the odd number problems worked out, plus giving all the answers to the even number problems, so that when you work those out, you'll see if you got these right. So quite an involved little set there, preparing you for working with ellipses. Good luck on all these problems, and thanks for viewing.